Hi everyone, you're welcome to the SOC Analyst Professional course, the Module 1. We'll be discussing SOC foundations in this module. In this module, we'll begin by introducing the operational structure, detection methodologies, and analytical frameworks used within a security operations center. In simple terms, this module helps students understand how a SOC works, how threats are detected, and how analysts investigate security incidents inside an organization. Students will develop the foundational skills required to monitor security events, investigate alerts, interpret logs, and understand attacker behavior. Let me briefly explain some of these key terms. Security events refer to activities that occur within systems or networks, such as logins, files, access, or network connections. Alerts and notifications generated by security tools when suspicious activity is detected. Logs are records of activities that happen in systems, applications, and networks. Attacker behavior refers to the patterns or technique that attackers use when attempting to compromise systems. This module also introduces globally recognized cybersecurity frameworks such as cyber kill chain. Now, the cyber kill chain is a framework used to understand the different stages of a cyber attack, from the initial reconnaissance stage to the final stage where attackers achieve their objective. Now, and military attack framework. What is the military attack? The military attack, the military attack framework is a global knowledge base that documents real-world attacker tactics, techniques, and procedures (TTPs) used by cyber adversaries. These frameworks help analysts to understand how attacks progress, identify attacker techniques, improve threat detection capabilities. You understand? By the end of this module, learners should be capable of performing basic alert triage, log interpretation, and threat detection analysis in a SOC environment. Security Operations Center Fundamentals. Now, in this submodule, we'll be discussing the concept of a Security Operations Center. A Security Operations Center is a centralized unit responsible for monitoring, detecting, analyzing, and responding to cybersecurity incidents across an organization's infrastructure. To simplify this, a SOC is essentially the cybersecurity control room of an organization. It is where security professionals monitor systems and networks to detect and stop cyber threats before they cause damage. Modern organizations rely heavily on digital systems, including cloud platforms, corporate networks, servers, endpoint devices such as laptops and desktops. All these systems continuously generate large volumes of security related data, such as login records, system logs, and network traffic information. The SOC acts as the central nervous system of an organization's cybersecurity defense, ensuring that threats are identified and mitigated quickly. Most SOC environments operate 24 hours a day, 7 days a week, providing real time security monitoring. Now, let's go to the core responsibilities of a SOC. SOC team perform several critical tasks. Continuous monitoring. Security tools constantly generate alerts whenever suspicious activity is detected. SOC analysts monitor these alerts continuously to identify potential threats. This monitoring usually occurs through security dashboards, especially those provided by SIEM platforms. Threat detection. SOC analysts analyze logs, alerts, telemetry data to determine whether suspicious activity represents a real cyber attack. Telemetry data refers to system generated data that provides visibility into system behavior. Investigation, incident investigation. When an alert appears suspicious, analysts investigate it by examining system logs, endpoint activity, network traffic, user behavior. This investigation helps determine whether the alert represents a true security incident. Incident response coordination. Once a threat is confirmed, SOC teams coordinate with IT teams and incident response teams to contain and remediate the threat. Now, containment means stopping the attack from spreading, while remediation means removing the threat and restoring systems. We'll go to documentation and reporting. All incidents and investigation must be documented. Now, this documentation helps organizations maintain regulatory compliance, track security incidents, improve future threat detection. All right, good. SOC core component. A SOC functions effectively when three key components work together. These components are often referred to as people, processes, technology. If any of these components is weak, the overall effectiveness of the SOC is reduced. Now, let us talk about the first one, which is people. The people component refers to the cybersecurity professionals responsible for monitoring systems, analyzing threats, responding to security incidents. Different roles exist within a SOC, and each role has specific responsibility. Okay, now let us go to the processes. The processes, well defined procedures. Okay. The processes. Processes define how security operations are carried out within the SOC. All right. They ensure that every alert and incident is handled consistently and efficiently. As you can see, it is well defined procedures and playbooks. that ensure consistent, efficient, and standardized handling of security incidents. Now, the third one, which is technology. Okay, technology. There are robust security tools, monitoring system, and advanced analytics that enable the swift detection and analysis of threats. So let us talk about people. The people component refers to the cybersecurity professionals responsible for monitoring systems, analyzing trends, and responding to security incidents. Different roles exist within a SOC, and each role has specific responsibilities. Tier 1 SOC analyst, which in other words can be alert monitoring and triage. Tier 1 analysts are considered the first line of defense in the SOC. The primary responsibility is to monitor alerts generated by security tools such as SIEM, EDRO, IDS. Since thousands of alerts may be generated daily, Tier 1 analysts must quickly determine which alerts represent real threats. Key responsibilities include monitoring the SIEM dashboard for alerts, reviewing logs for suspicious activity, filtering out false positives, filtering out false positives, performing initial investigations, escalating confirmed threats to higher level analysts, documenting alert details in incident management systems. Tier 1 analysts focus mainly on alert validation and triage rather than deep forensic investigation. Tier 2 SOC analyst, which is the incident investigation. Tier 2 analysts perform more detailed investigations when alerts are escalated from Tier 1. They analyze logs and evidence to determine the impact and root cause of an attack. Their responsibilities include investigating complex incidents. Now, they analyze escalated alerts to uncover the scope and root cause of the attack. Analyzing logs and telemetry. Now, they examine endpoint logs, network logs, authentication logs to trace attacker activity, accessing impact and containment. They determine how serious the attack is and coordinate containment actions, identifying attack techniques. They determine the tactics, techniques, and procedures used by attackers. TTP describes how attackers operate and carry out attacks. Tier 3 SOC analyst, which is threat hunting and advanced analysis. Tier 3 analysts are highly skilled cybersecurity experts responsible for advanced investigations. They perform proactive threat hunting. Threat hunting involves actively searching for malicious activity that may not yet have triggered security alerts. Their responsibilities include conducting proactive threat hunting, analyzing malware samples, developing new detection rules, researching emerging cyber threats, and improving detection capabilities. Tier 3 analysts also help investigate advanced persistent threats, APTs. An APT is a long term attack where adversaries remain hidden inside a network for extended periods. Go to SOC engineer. SOC engineers maintain the technical infrastructure of the SOC. Their responsibilities include deploying and configuring security tools, setting up security platform and appliances, integrating log, integrating log sources into the SIEM, developing detection rules, automating response actions, ensuring platform performance. SOC engineers ensure that analysts have the tools they need to detect threats effectively. Now let's talk about the incident response team. The incident response team handles containment and recovery when a security breach is confirmed. Their responsibilities include containing the attack, preventing the incident from spreading further, isolating systems, removing compromised systems from the network, removing malware, eradicating malicious software from infected system, conducting forensic investigation, that is analyzing digital evidence to determine the root cause of the attack, and restoring systems, that's bringing back systems to normal operation and preparing incident reports. The SOC manager. The SOC manager oversees the entire SOC operation. Their responsibilities include managing SOC staff, coordinating analysts and engineers, ensuring incident response procedures are followed, improving SOC strategy, that is monitoring SOC performance. Okay, SOC managers track key performance indicators, which is KPIs, to measure the effectiveness of the SOC. They also report security metrics and incidents to organizational leadership. All right, now let's go to the processes. Remember, we talked about people in the first example. The second one is processes. Now, processes define how security operations are carried out within the SOC. They ensure that every alert and incident is handled consistently and efficiently. Without structured processes, analysts might respond to threats inconsistently, which could lead to missed threats or delayed responses. Alert triage procedures. Alert triage refers to the initial evaluation of security alerts. Since SIEM systems generate many alerts, analysts must quickly determine which alerts require investigation. The triage process usually involves reviewing alert details, checking the source of the alert, analyzing related logs, determining whether the alert is legitimate or a false positive. Alerts are then categorized based on severity levels. Incident escalation workflow. If an alert cannot be resolved by a tier 1 analyst, it is escalated to tier 2 or tier 3 analyst. An escalation workflow ensures that critical threats receive immediate attention. Analysts know when to escalate incidents. Investigation responsibilities are clearly defined. Escalation is usually based on factors such as: 1. Severity of the threat, sensitivity of affected systems, potential business impact. Incident response playbook. Playbooks are step by step guides used to respond to specific types of incidents. Examples include phishing incident response, malware infection response, unauthorized access investigation, data exfiltration response. Playbook help analysts respond quickly and consistently. Reporting procedures. Every incident must be documented. Reporting procedures ensure analysts record timeline of events, investigation steps, evidence collected, actions taken to contain the threat, and final resolution. Proper documentation helps organizations improve security practices and meet compliance requirements. Post incident review. After an incident is resolved, the SOC performs a post incident review. The purpose is to identify what caused the incident, whether detection could have occurred earlier, improvement needed in detection rules or processes. This process helps organizations strengthen their security defense. The third, which is technology. We spoke about people, processes, and technology, which is the third one. Technology provides the tools used by SOC analysts to detect and investigate threats. Modern SOC environments rely on multiple security technologies working together. SIEM, let's talk about SIEM, which is Security Information and Event Management. SIEM system serve as the central platform of the SOC. They collect logs from multiple sources such as servers, endpoints, firewalls, cloud platforms, and applications. The SIEM analyzes these logs and generates alerts when suspicious activity is detected. Examples include Splunk, Microsoft Sentinel, IBM QRadar, Elastic SIEM. Okay, these are examples of SIEM tools. Let's talk about EDR, endpoint detection and response. EDR tools monitor activity on endpoint devices such as laptops, desktops, and servers. They detect suspicious activities like malware execution, unauthorized process activity, privilege escalation attempts, suspicious network connections. Examples include Microsoft Defender for Endpoint, CrowdStrike Falcon, Sentinel One. Now let's go to firewalls. Firewalls control network traffic entering and leaving an organization's network. They help prevent unauthorized access by enforcing security policies. Firewall logs record information such as source IP address, destination IP address, ports used, and allowed or blocked connections. IDS and IPS. IDS, which is Intrusion Detection System, monitors network traffic for suspicious behavior. IPS, which is Intrusion Prevention System, goes further by automatically blocking malicious traffic. These tools detect attacks such as network scanning, exploitation attempts, malware communication. Talk about threat intelligence platform. Threat intelligence platform provide information about known cyber threats. This includes malicious IP addresses, malware signatures, known attacker tactics. Threat intelligence helps analysts identify known threats more quickly. All right, so let's go to SOC workflow. How does the SOC function? SOC workflow describe the process analysts follow from the moment an alert is generated until the incident is resolved. When we talk about the SOC workflow, we are referring to the step by step process that security analysts follow when handling security alerts and incidents. In a security operations center, thousands of security events may occur every day. Because of this, analysts must follow a structured workflow so that no threat is ignored and every alert is handled properly. Understanding this workflow is very important for SOC operations because it helps analysts respond to security threats quickly, consistently, and professionally. The SOC workflow usually follows several key stages, which is one, alert generation. The first stage of the SOC workflow is the alert generation stage. At this stage, security tools detect suspicious activity and automatically generate alerts. An alert simply means a notification that something unusual or potentially dangerous has been detected in the system or network. These alerts are generated by different security tools such as SIEM, spoke about it the first time, which is security information and event management, endpoint detection and response tools, which is the EDR, firewalls, intrusion detection system. Now, some common examples of alerts include one, multiple failed login attempts. This may indicate that someone is trying to guess a user's password using a technique known as a brute force attack. Now, malware detection on an endpoint. An endpoint refers to devices such as laptops, desktops, or servers connected to the network. If malicious software is detected on such a device, the system generates an alert. Suspicious outbound network traffic. This happens when a device inside the organization tries to communicate with an unusual or potentially malicious external server. All these activities trigger alerts that will be reviewed by SOC analysts. Two, alert validation. Once an alert is generated, it moves to the next stage called alert validation. At this stage, Tier 1 SOC analysts review the alert to determine whether the alert is legitimate or not. In other words, the analyst must determine whether the alert represents a real security threat or just a false alarm. To validate the alert, analysts examine several things, including log data. Now, logs are records of activities that occur within systems, applications, and networks. Okay? They also review what? User activity. Analysts check what actions the user performed around the time the alert was what? Triggered. The third, they also analyze system behavior. System behavior involves checking whether the system behaved abnormally, such as running unknown programs or making unusual connections. If the alert turns out to be a false positive, meaning the system flagged something suspicious, but it is actually harmless, the alert may simply be closed. Go to the third one, which is alert triage. If the alert appears suspicious and cannot be dismissed as a false positive, it proceeds to alert triage. Okay? Triage means prioritizing and categorizing alerts based on their severity and urgency. At this stage, analysts perform deeper analysis to determine how serious the alert is. This may involve reviewing related logs. Analysts gather additional logs from different systems to understand what happened. That is when they review related logs. To checking user activity, they investigate whether the user actions were legitimate or suspicious. 3. Identifying potential indicators of compromise (IOCs). Indicators of compromise are pieces of evidence that suggest a system may have been breached. Examples of IOCs include malicious IP addresses, suspicious file hashes, unknown processes running on a system. The goal of triage is to determine whether the alert should be escalated for further investigation. All right. Investigation. If the threat appears legitimate, the next stage is what? Investigation. During this phase, analysts perform a more detailed analysis of the incident. They attempt to answer several important questions, such as how did the attack occur? Now, this involves identifying the attack method used by the attacker. That is why that question is being asked. Go to the second one, which is which systems were affected. Analysts determine whether the attack impacted one device or multiple systems across the network. Third one is, was any data compromised? This is extremely important because attackers often attempt to steal sensitive data, such as customer information, passwords, or confidential documents. The investigation phase helps analysts understand the scope and impact of the incident. The fifth one, which is escalation. If the incident is serious or requires more expertise, it is escalated to higher level analysts or the incident response team. In most in most environments, analysts are organized into tiers. Okay, tier one analysts, like I explained, they are do initial alert monitoring and validation. Tier two analysts, they perform deeper investigation and threat analysis. Tier 3 analysts or threat hunters, they handle advanced threats and complex incidents. Escalation ensures that more experienced personnel, sorry, it ensures that more experienced personnel handle critical security incidents. So let's go to containment and response. At this stage, the incident response team takes action to stop the attack and prevent further damage. This stage focuses on containing the threat and removing the attacker from the environment. Some common response action include isolating compromised systems. All right, this means disconnecting infected devices from the network so the attack cannot spread. Two, blocking malicious IP addresses. If the attacker is communicating with the network from a known malicious IP address, that IP can be blocked. Removing malware. Security teams remove malicious software from infected systems. Okay. Resetting compromised credentials. If attackers have obtained login credentials, those passwords must be reset immediately. The goal here is to stop the attack and restore the environment to a secure state. The seventh one, documentation and closure. The final stage is documentation and closure. Once the incident has been resolved, the SOC team must document the entire investigation process. This documentation includes what triggered the alert, how the investigation was conducted, what actions were taken to respond to the incident, the final outcome of the incident. Documentation is extremely important because it helps organizations improve detection capabilities. Future attacks can be detected faster. Strengthens security defenses. Now, lessons learned from the incident can be used to, improve security controls. Prepare for future incidents. Proper documentation ensures the SOC team becomes more effective over time. In summary, the SOC workflow ensures that every security alert is handled systematically from detection all the way to resolution and documentation. Okay, so for the hands-on lab module 1.1 for SOC environment familiarization, um, and the title of this lab is Understanding SOC Tools and Operational Rules. In this hands-on lab, we are going to familiarize ourselves with some of the most commonly used tools inside a security operations center. The goal of this exercise is to help you understand different technologies SOC analysts interact with during daily monitoring, detection, and investigation activities. Now, in real SOC environments, analysts rely on several tools to monitor security events, detect suspicious activity, investigate potential security incidents, and respond to cyber threats. Okay? By the end of this lab, you should be able to recognize common SOC tools and understand the role each one plays in cybersecurity operations. This exercise focuses on tool familiarization, meaning we are learning what these tools are used for and how they fit into SOC operations. So, step one, I need you to open your web browser. I'm already in my own web browser. It could be your Google Chrome, Microsoft Edge, or Mozilla Firefox. So, I'll be using um, I'll be using my Google Chrome. Sorry, I'll be using my Microsoft Edge. Now, search for the following SOC tools. All right, let us start with Splunk. So, I'll be searching for Splunk.com. Splunk.com. Okay, now this is Splunk.com. Hmm? Splunk is a security information and event management platform that is used to collect, analyze, and correlate logs from different systems across an organization. Okay, SOC analysts use Splunk to monitor security alerts and investigate suspicious activities. So this is the website of the Splunk. So on your own, you go through it. Okay, go to the website, get the necessary information, come here, click the platform, get necessary information about this website, understand what this website does. Okay, the next website I like you to check out would be Microsoft Sentinel, and it would be azure.microsoft.com/products slash Microsoft Sentinel. So this is it. All right. So read extensively. This is the overview, the capabilities. Read and understand what it is used for. Okay. Microsoft Sentinel is a cloud native SIEM, all right, and security analytics platform that is developed by Microsoft. It helps organizations detect threats, investigate incidents, and respond quickly using cloud scale security monitoring. Now, the third one I'd like you to check is CrowdStrike Falcon. And the website is simple, which is just crowdstrike.com. Now, what is this CrowdStrike platform? It is an endpoint detection and response platform, which is EDR. EDR tools monitor endpoint devices such as laptops, desktop, and servers to detect malicious activity like malware infections or suspicious processes. All right. So also go through it, get the necessary information, understand what they do. Last on the list is Security Onion. Let us check it out. And the website is securityonionsolutions.com. Now this is it too. So you read about it, okay? And what does this Security Onion do? It is an open source security monitoring platform used for network security monitoring, intrusion detection, log analysis, threat hunting, and it is commonly used in SOC training environments and cybersecurity labs. So, after opening all these websites, please read the short description of what each tool does. While reviewing the information, focus on understanding what type of security tool each one represents. Ask yourself questions like: is this tool used for log collection and analysis? Does it monitor endpoint devices? Is it designed for network security monitoring? Okay. The purpose of this step is to help you identify the role each tool plays within a SOC environment. Okay. So by the end of this exercise, you should understand the difference between SIM platforms, which is used for log collection and security monitoring, like Splunk, all right? EDRO solutions, which is used to monitor endpoint devices, like Microsoft Sentinel, like CrowdStrike, all right? And network security monitoring tools used to detect attacks in network traffic, okay? These tools form an essential part of modern security operation center. Shalom. Welcome to Module 1.2. In modern cybersecurity operations, organizations generate massive amounts of data from many different systems. These systems include computers and servers, applications and software programs, networks and routers, user activities within systems. All right. Every action that happens inside an organization's IT environment creates a log entry. A log is simply a record of an activity that occurred inside a system. For example, when a user logs into a computer, a log is created. When someone opens a file, a log is generated. When a computer connects to a network, that activity is recorded in a log. Some common examples of logged activities include login attempt, file access event, network connection, application activity. These logs may contain important security information that help detect cyber attacks. However, modern organizations may have hundreds or even thousands of systems generating logs at the same time. Manually reviewing all these logs across so many systems would be extremely difficult and time consuming. Because of this challenge, cybersecurity professionals developed a technology, all right, known as SIEM platform. A security information and event management platform, which is SIEM, collect logs from many systems, analyzes them, and helps security teams quickly detect suspicious or malicious activity. For SOC analysts, the SIEM platform is usually the primary environment where security investigations begin. When an alert is triggered, analysts typically start their investigation inside the SIEM dashboard. Now, what is SIEM? SIEM stands for Security Information and Event Management. It is a cybersecurity technology that is designed to collect, store, analyze, and correlate security data from multiple systems within an organization. Let us briefly explain these functions. To collect, SIEM gathers logs and security events from many different systems. To store, it means that the collected logs are saved in a central location so that they can be reviewed later. Now, to analyze means that the system analyzes log data to identify patterns that might indicate suspicious activity. To correlate means that it is linking multiple events together to determine whether they are related to a potential attack. SIEM systems allow organizations to monitor their entire IT infrastructure from a centralized place, from a centralized platform. A centralized platform simply means a single system where security teams can view and analyze logs from many different devices at once. The main purpose of a SIEM is to identify potential security threats by analyzing patterns in security logs and generating alerts when suspicious behavior occurs. Now, why is SIEM important in SOC operations? SIEM plays a critical role in Security Operations Center (SOC) because it provides the tools analysts need to detect and investigate threats efficiently. Okay, SOC analysts rely heavily on SIEM platforms for several reasons. First is to centralize security logs. Organizations operate many different systems that generate logs. This system includes servers, endpoint devices such as laptops and desktops, firewalls, cloud platforms. All right? Without a SIEM system, logs from these systems would be stored separately across different devices, making it very difficult to monitor security events. SIEM platform aggregates these logs into a single platform. The word aggregate simply means to collect data from multiple sources and bringing it together in one place. This centralization makes security monitoring much easier for SOC analysts. Okay. The second is to detect suspicious activity. The importance of SIEM in SOC operation to detect suspicious activity. SIEM platform analyze patterns within log data. When abnormal or suspicious activity is detected, the SIEM generates an alert. An alert is a notification sent to SOC analyst indicating that something unusual has occurred and needs investigation. Examples of suspicious activities include repeated login failures, suspicious network connections, unauthorized system access, and improved incident response. Now, because SIEM platform provides centralized visibility into security events, SOC analysts can quickly investigate incidents. Centralized visibility means having a clear view of activities happening across the entire network from one interface. Early detection allows security teams to respond quickly before attackers cause serious damage. Another reason why SIEM is important in SOC operation is to correlate security event. A single event may not necessarily indicate an attack. For example, one failed login attempt is usually normal. Okay. However, if there are multiple failed login attempts occurring within a short period, this might indicate a brute force attack where an attacker is trying many passwords to gain access to an account. SIEM systems use event correlation to connect related events and identify suspicious patterns. Event correlation means analyzing multiple events together to determine whether they form part of a potential attack. The fourth reason why SIEM is important in SOC operations is to improve incident response. Because SIEM platforms provide centralized visibility into security events, SOC analysts can quickly investigate incidents. Centralized visibility means having a clear view of activities happening across the entire network from one interface. Early detection allows security teams to respond quickly before attackers cause serious damage. Key functions of SIEM platforms. SIEM platforms perform several essential functions that help organizations monitor security events. These key functions include log collection, generation, log normalization, and event correlation. Now, let us examine each of these functions. Log collection. The first major function of a SIEM platform is log collection. SIEM systems collect logs from various systems across an organization's infrastructure. Common log sources include Windows servers, Linux systems, endpoint devices, firewalls, network devices, applications, and cloud devices. So, each of these systems generates logs containing security relevant information such as login attempts, system errors, file access events, network connections. SIEM platform collect all these logs and store them in a centralized location for analysis. Go to the second one, which is log normalization. After log collection, we have log normalization. Different systems generate logs in different formats. For example, Windows may record login events differently from Linux. Firewalls may record network connections differently from applications. Because of these differences, it will be difficult to analyze logs consistently. SIEM platforms solve this problem through a process called log normalization. Log normalization means converting logs from different formats into a standardized format. This allows analysts to analyze and compare data more easily across different systems. For example, logging events from different operating systems may appear different originally, but SIEM converts them into a common structure for easier analysis. The third is event correlation, which is this. Another important SIEM function is this event correlation. Event correlation involves analyzing relationships between multiple events to identify suspicious patterns. For example, consider the following sequence of events: multiple failed login attempts, a successful login occurs, privilege escalation happens. Let us explain privilege escalation. Privilege escalation occurs when a user gains higher access permissions than they originally had. For instance, if a normal user suddenly obtains administrator level access, this could indicate malicious activity. When SIEM platforms detect patterns like this, they may indicate a brute force attack followed by account compromise. An account compromise occurs when an attacker successfully gains unauthorized access to a user account. The fourth one is alert generation. When the SIEM detects suspicious patterns, it generates alert. These alerts are sent to SOC analysts for further investigation. Alerts may indicate events such as suspicious login activity, malware detection, unauthorized privilege escalation, and data exfiltration attempt. Now, data exfiltration refers to the unauthorized transfer of sensitive data from an organization system to an external location. Alerts are usually categorized based on severity levels, such as low severity, medium severity, high severity, and critical severity. This classification helps analysts prioritize which alerts should be investigated first. Investigation and search. SIEM platforms also provide powerful search and investigation capabilities. SOC analysts can use the SIEM interface to search logs and analyze security events. Analysts may query logs to answer questions such as which user logged into the system at a specific time, which IP address accessed a server, what processes were running on a particular endpoint. An IP address is a unique identifier assigned to devices connected to a network. Of course, a process refers to a program or application currently running on a system. This search, this search functionality makes SIM platform extremely powerful. This search functionality makes SIM platforms extremely powerful investigation tools. Now, common SIM platforms used in SOC. You have several SIM platforms, okay, that are widely used across the cybersecurity industry. Number one is Splunk. Splunk is one of the most popular SIEM platforms used by SOC teams. Key features include powerful search capability, real-time monitoring, custom dashboards, advanced analytics. A dashboard is a visual interface that displays security data in charts, graphs, and tables. Many cybersecurity training programs use Splunk because it is powerful yet relatively beginner friendly. The next is Microsoft Sentinel. Microsoft Sentinel is a cloud based SIEM platform built on Microsoft Azure. A cloud based platform means the system runs on remote servers managed by cloud providers rather than on local hardware. Key features include cloud native architecture, integration with Microsoft security tools, AI driven threat detection, and scalable log collection. Scalable means the system can handle increasing amounts of data as the organization grows. Another good tool is IBM QRadar. QRadar is an enterprise level system solution designed for large organizations. Key features include advanced threat detection, built in correlation rules, network behavior analysis. Okay, it is widely used in large enterprise SOC environments. And the fourth tool is Elastic SIEM. Elastic SIEM is an open source SIEM platform built on the Elastic Stack. Open source software means the source code is publicly available and can be modified or customized. Key features include real-time analytics, flexible search capabilities, visualization dashboards. Okay. Now, it is often used by organizations that prefer open source cybersecurity tools. Key components of a SIEM system. Understanding the architecture of a SIEM system helps analysts understand how data flows through the system. The main components include data sources, log collectors, and storage. Let's talk about data sources. Data sources are the systems that generate logs and security events. Examples include servers, firewalls, endpoint devices, cloud platforms, and network routers. This system produces the raw data that system platforms analyze. Log collectors. Log collectors are responsible for gathering logs from various systems and sending them to the same platform. This ensures that all security events are captured and centralized for analysis. And you have storage. SIEM platforms store collected logs for several purposes, including security investigations, compliance requirements, and historical analysis. Many organizations store logs for months or even years, depending on regulatory or compliance requirements. Compliance requirements are rules or regulations organizations must follow to protect sensitive data. Okay, so this is a SIEM dashboard. This is a Splunk dashboard. All right, if you want to search, this is the search bar. If you want to search for events within a certain time range, That is where I clicked on was search and reporting. Okay, so search and reporting. You can come here and this is to check within a certain time range. Last 30 seconds, 1 minute, 5 minutes, and all of that. This is it all. If you want it to be all time, okay? This is the dashboard. This is the dashboard. Okay. Okay. I'm just taking you people around it. This is my account on Splunk 10.2. All right. These are reports. As you can see, nothing has happened for Bucket Merge Retrieve config settings. I'm just taking you guys through, um, you know, the overview of Splunk tool that I'm using. So if you want to search for an event, okay, that will be in our next class. I'll teach you how to install Splunk. This is where you come to, all right. In real time, you have 30-second window to know what has happened for the past 30 seconds, 1 minute window, 5 minutes window, 30 minutes, 1 hour, all time, and all of that. Today and all of that. Yeah. So this is just how the Splunk tool looks like. Okay. So in our next class, we'll deal with installing Splunk.